Our next speaker is Bernard Foing. Bernard Foing is from France. He has a PhD in astrophysics. He's done astronomy in Chile. He was the champion of the Smart 1 mission, Europe's first mission to the moon, and served as the principal project scientist for that. You know, he's been all over the place. He's the head of the International Lunar Exploration Working Group. His wife, Pascal Arenfund, is the president of the International Astronomical Federation, and he has led expeditions to our Mars Desert Research Station in Utah. He's one of the chief instigators of European interest in Mars and moon analog research. So without further ado, let's hear from Bernard.
Thank you very much, Robert. So welcome from Europe. It's really a pleasure to talk at this Mars convention because, in particular, about the EuroMoonMars program, because this program, in fact, was born 12 years ago, inspired very much by our first expedition that we conducted at the Mars Desert Research Station with the support of Robert Zubrin, with Carol Stoker, with the support of Chris Mackey and others. And so I would like to share with you what it has become after 12 years. So I've prepared for you a presentation of our EuroMoonMars highlights. Okay, that's a program now that we have conducted to perform science. You all hear me and you can see my slides? Just
yes,
check.
We can see them.
Excellent. And but also we develop instruments. We test them in analog site or in the laboratory in extreme conditions. And also we perform analog missions to train astronauts. And you can see we started this with this EuroMoonMars campaign in 2009 at Mars Desert Research Station. In the meantime, we have conducted a series of other campaigns at MDRS, but also we tried to build some facilities in Europe, and we have used also facilities in Iceland, in Hawaii with ISIS, and we are now also exploiting some of this work with a network of institutes and collaborators. So every year we have like 10, 15 new members that are joining our team. And I've put some of the names of the recent collaborators here. So, oh yes. So I wanted to say, we started actually after we launched Mars Express in 2003. So our main focus was to analyze the data from this beautiful scientific mission that have provided a comprehensive study of Mars, its atmosphere, its environment, the history of water on Mars, meteorology, climate, aeronomy, and also eventually some views of Phobos, and some discoveries, in particular, the evidence of recent volcanism on the surface of Mars, where we have been able to date calderas in some of the Tarsis mounts, the Albortolus, Asclepius mounts, Olympus mounts, showing that volcanism on Mars has been also present in the recent geological time. Also, big revolution in our understanding of the history of mineral on the surface of Mars from a period where Mars was eventually wet and warm to a period now where it's cold and arid. And we have also some mineral signatures from this ancient time that were measured with Omega infrared spectrometer, and we can have access then to the water history on Mars. And this can be done with a spectrometer using also the information from the high resolution stereo camera. So with the camera in particular, we could measure regional geology and chronology, looking at the traces of hydrology on Mars with chaotic regions, mega flood, buried ice, and also we can study some tectonic features on the surface of Mars. So a strong interest for ice and glaciers, so in this polar layered deposit, but also we have found at tropical latitude some sign of a possible frozen sea, a packed ice that was present 5 billion years ago near Elysium. And also we have had some evidence, like Carol was mentioning, that based on obliquity variation that were calculated by Jacques Lascarty in France and others, showing that there are big changes in obliquity that lead to redistribution of ice from the pole to the tropics, and that created some ice ages in the tropics that you can in fact follow, and you have some remnant information from the images that we have analyzed. Eventually we are able to also reconstruct the climatic history of Mars. Also, we have used a radar instrument, the MARSIS, that were able to penetrate kilometers below the polar layer deposit to find some signature of a liquid water. So subglacial lakes. So by the intersection of the different paths that give a consistent information. Also, we have been monitoring over the several Martian years the variation of climatic quantities such as temperature, ozone, water, oxygen, and dust, and that are now compared to global climate models to really understand the climatology of Mars. So this is a little gallery, a summary of some of the revolution for Mars Express, 3D high resolution images, evidence of water ice at the pole, possibly methane detected at that time already, recent volcanism, and some correlation between water and ozone, studies of Phobos, also collaboration with NASA rovers providing images and also data relay, and so understanding the Martian water process, and as well the mineral history of Mars and some of the radar results that I have mentioned. So that was our status. Also, now we are using the data from the ExoMars 2016 mission with a trace gas orbiter, which is still in operation with beautiful stereo images and also measurement of the atmosphere and the, of the ice, subsurface ice. And we had also a demo module for landing that didn't work so well, but we have learned a lot out of that. Now we are preparing for ExoMars 2022. We have defined the place where we are going to land in Oxyaplanum. And this mission will really look for life, extinct or extant life, in particular with a drill that will go to 2-meter depths in an area where organics can survive long exposure to cosmic rays. And we have an exquisite suite of instruments on board. On this rover, we have a payload called PASTA, where we have a panoramic camera, PanCam, infrared spectrometer, close-up imager, ground penetrating radar, neutron detector, and also even in the borehole of the drill, we'll have an infrared spectrometer. And then we'll acquire some samples that we'll put in an analytic laboratory rover, and there you will measure further with the infrared spectrometer, with the Raman spectrometer, and very sophisticated mass spectrometer called MoMA. So that was our context. And now also a bit about Smart One that Robert mentioned, which is my baby. So we had also the same year launched Smart One, mostly a technology mission with solar electric propulsion, instrument miniaturization, and also showing you can do things faster, cheaper, and harder, a bit like we did with Mars Express. And illustrating that we have some data where our first focus was to analyze those data in terms of the tectonics of what shape rocky planets, with impact, bombardment, volcanism, polar vision, and we even did impact experiment, one more impact on the moon by observing our own final impact from a telescope from Canada, France. Eventually also, we looked at places where we could go in the future with a robotic village or with a human outpost. And so that's in the polar regions and a very interesting area in permanent shadow where volatiles have been found. And also we have mapped the illumination over the whole year. And in particular, we found that very close to the South Pole, to the Shackleton crater, there is a kind of peak of light, which is 100% illuminated in winter and in summer and 80% in winter. So also we have used a smart one because it was the first moon mission of the millennium to have a collaboration with other countries, with the US, with Japan for their Kaguya mission, with China for the Chang'e mission, and after ESA contributed also to provide some ground station support for the Chang'e mission, both the orbiter and the landers, and also the Indian mission Chandrayaan-1, where we put 3 instruments on board. And we also collaborated with the US mission, LRO, GRAIL, LADI, and so on. And de facto, there have been more than 15 orbiters around the moon. Now we are in the phase of a robotic village on the moon, where in 2013, the Chinese have put Chang'e 3 on board and still in operation after 8 years. So we have a permanent robotic village, and it has deployed a rover called the U2, the Jade Rabbit, that has a performed measurement of the world. The twin lander has been put on the far side of the moon in 2019 for the Chang'e 4 mission, and in 2020, the Chinese have put Chang'e 5, which delivered also an automatic sample return from some of the youngest area of the moon on the near side, and the age has been just published recently in a series of Nature paper of 2 billion years. So 25 years ago, we created the International Lunar Exploration Working Group to see how we could prepare a roadmap for a future human exploration utilization toward the moon village. So with this orbital fleets, then robotic village, then human for short stay, human outpost, and then permanent human and robotic base with permanent occupation, like we have now had the ISS inhabited for 22 years. The idea that we could have also then rotation in this base with humanity present forever. And that's the view from the ESA side. The destination for human exploration are low Earth orbit, the moon and Mars, and we go step by step. But for the moon, we are contributing the European Service Module that is going to bring the Orion capsule to the moon and safely back, and will bring the 4 astronauts from 2023 on. But already next year, we'll have an automatic flight of this. And at some stage, we'll have the Artemis 3 that will bring, yes, the first woman to the surface of the moon, the next American of color there. But also, there will be a series of missions every year, and Europe will be part of that. So that's the views, how we are trying to help to advance in some of these challenges to get there for this moon village, to operate, communicate, survive, also have a mobility, exploit resources, use a partnership between human and robot. But the novelty is that we are not going to do that only with government taxpayers' money alone, but also we try to involve users, collaborators from new space, from non-space sectors. And as you see, this lunar village is going on, and there are a series of robotic missions in the next years from international partners, from commercial partners, and also we have human mission. Which leads me to, but what can we do now with the young professional? That's the idea of the EuroMoonMars program. We try to prepare instruments. In particular, we build a lander in the frame of this Google and Express competition. We build a mock-up lander where we tested how to place instruments, spectrometers, rovers, and also test the teleoperation of this. We also practice cooperative robotics between lander and a series of rovers which have different functions. We learn how to teleoperate that from a cozy control center that we had built, a bit inspired from our experience with the Mars Desert Station. We teleoperate the lander and the telescope from several thousand kilometers distance, even intercontinental. Now, more recently, we have worked with some of the top teams of mechatronics and robotics in Europe, the German Aerospace Agency, DLR. We deployed almost on the moon. You can see that the Etna volcano, 2 very autonomous, intelligent rovers that can capture some payload box, deploy them with seismometers, And next year, we will deploy also some sample analysis box and a series of 4 antenna that will perform very low frequency measurement like we want to do on the far side. So that's what we do to prepare for a sustainable presence on the moon and then to Mars. Now back to Mars. That's coming back to the story where you had these beautiful images from Mars Express of Juvente Casme, and we found some very similar landscape on Earth. And this is the landscape surrounding the Mars Desert Research Stations, where we had conducted a number of campaigns. I was myself there. We had a technology campaign together with Carol Stoker, testing instrument, and that was a campaign where I was commander of, and we conducted that several years. So that's how really the EuroMoonMars program was born, with a focus on doing field research and laboratory research, geology and astrobiology, also testing instruments, cameras, spectros, rovers, drones, testing traverses, sampling, radar, and also optimizing habitat technologies for what could be a future habitat on the moon or Mars. But of course, as well, a lot of learning in the area of human factors, human performance, how to organize the astronaut, also the extravehicular activities, and the medical aspect as well, and the psychological. Also, we found it was a great vehicle for training young researchers together with advanced researchers for learning to communicate to their peers, to the public, and we try also to have a strong research output. So with 110 publications now, including 15 referred papers. In particular, we had a special issue of the International Journal of Astrobiology with Pascal Ehrenfreund, with Carol Stoker, really editing this volume. So here an example of the experiment that we are on board, X-ray diffractometer, X-ray fluorescence, which was provided by Dave Blake from NASA Ames. That's an orange box you can see here, and that's a prototype, a terrestrial prototype of the one which was launched for the MSL Curiosity rover. Visible infrared reflectance, Raman spectroscopy, that's very relevant because on ExoMars we will have also Raman microscopy as well. And you can see some of the crew in the ground laboratory of the MDRS making the measurements. And then we had also outside instrument, multiple camera, ground penetrating radar, which was provided by JPL and by NASA Ames. We had also a drill, because with Carol, we have always the largest suite of drills. And then we have shown that you need 3 astronauts with a suit to operate this drill. And we got nice samples where you could measure as a function of depth, the mineralogy, but also the microbial content. We also tried to do some astrobiology experiments, taking samples and measuring them with various techniques. And we found some very interesting result of large microbial diversity over the areas. And at 100-meter distance, you had a very different microbial population. Then, inspired by this experience, we try to build our little EuroMoonMars research station, not in the desert, but close to the ESTEC Technical Center. So we equipped a laboratory. So these are some of our students from SuperAero. I log them for a few hours, and then they train how to operate rovers. They have also some instrument to spectrometers, microscope to analyze samples. And if they forgot some tools, they are not allowed to go outside, but they have a 3D printer, then they can print what is missing, like you will do when you're on the moon. You don't need to wait 5 days that they bring you what you have forgotten on Earth. We also did some tests of astrobiology laboratories to do some biological science, and as well test some planetary protection protocols, and also do some plant growth. Eventually, we go to the nearest volcano that we have from the Netherlands. That's a volcano that exploded almost yesterday, so 10,000 years ago. We had a big volcano exploding in the center of Europe that in 3 weeks deposited 30 meters of ashes. So we went there with our lander and instrument to test it, and in a similar condition like we would be on the moon. So we did a series of campaigns there, also with the Austrian Space Forum, providing an astronaut suit to see also the collaboration partnership between astronaut landers rovers. And you see here we arrive on the moon with a bit of a Photoshop. You can almost see we are there, and we tested some of these operations. Actually, with Austrian Space Forum, we also continued with a campaign in the ice caves, the karstic caves, where we tested a protocol for searching for life in a Martian ice cave. And you can see here the astronaut taking some sample in these beautiful ice caves. So as a summary, we have been exploring a number of analog sites. So Etna and Hawaii, Utah, Atacama Desert, Iceland. And I would like to give you some overview of some recent activities. We had a program, Lunar Lab, where we built in a glacier an habitat in ice. And then we tested some technologies of robotics, growing plants with a robot and artificial intelligence. We brought our lander there. We also have explored Iceland several times, the scouting campaign, and more recently, we had even a campaign organized by the young professionals themselves to deploy an emergency shelter in a lava tube in Iceland, and we are going to continue next year. Also, we have conducted some campaign together with the Analog Astronaut Training Center in Poland, where we had some isolation campaign. You can see the smiling crew before the 2 weeks isolation. They were also very happy after, because we fed them with plant grown in situ, and as well by what they have learned and by also the group experience. We also have performed some experiments using EuroMoonMars regolith analog to grow plants, and so we are ready for the next generation of plants to be grown on the moon, and also eventually we could send a robotic gardener there to take care of them before the human. So more recently, in the last 3 years, we have been also collaborating with Hank Rogers, the owner of the ICES base in Hawaii, to deploy a new set of campaign, a shorter duration in the ICES. And so I was there in 2018, where we tested some of the technology we wanted to test with new vehicle, a drone, also experiment to measure samples. And then, okay, I had also to perform some EVA activities in quite hostile conditions, a bit exhausting at this altitude, and with this very young and well-experienced astronaut. But eventually, we discovered some lava tubes that we explored. And the year after, we started a cycle of a new campaign. We call them EuroMoonMars, ICES, EMIS. And so these are the teams that we launched for 2 weeks in the base. So at the beginning, they have a system training for instrument, for communication, also cooking space food. And so the briefing, they managed to cook a beautiful cake just using the space food. And this is how the base look like. So it's fully autonomous in terms of solar power, and you have this beautiful volcanic landscape, very reminiscent of volcanoes on the moon or Mars. There are some views. So here's some views of the preparation for EVA. So the second year, so I had also some geology students. They did their master. One of them studied the hydrous alteration of basalt. And you can calculate that 100 years on Hawaii is equivalent to 100 million years on Mars. So you can explain why Mars basalt becomes red. And another looked at the composition of microbial communities in lava tube. Eventually, we discovered some lava tubes, and we mapped them. And I was comfortably in the control station in a blue planet, so not in the base, and directing the operation from a distance. It was they did a great job. So day 3, the antenna system broke down, so they had to make an EVA to repair it. And so that's a series of Hawaii operations. Now, close to us in Poland, we have also, in the last 2 years, conducted 9 campaigns called EuroMoonMars Poland and Pol, where we have a 1-week duration isolation, but in a base which is without window, completely isolated. And so we started at the time semi of pandemic with all safe distancing protocol. and they perform a lot of biological technology and group psychology experiment there. We change also, they don't have access to the time, so they have a time perception which is affected by the light cycle that we create. Eventually, this year we had a great event celebrating the 60 years of Gagarin, and so the astronauts also participated to that. Now, more recently, also in July, the first week after the opening of the pandemic in Italy, we managed to organize a campaign in Etna. So I had a team from a Dublin physicist operating drone, rover, camera, spectrometer. So we went to Etna. So this was the way to learn the protocol of what you would do with ExoMars from a lunar lander. So the idea that you could land on the moon or Mars, and after landing, you deploy a rover, and then you teleoperate the rover, and then you pick some sample that the scientists analyze, and later you analyze them in the laboratory. So it's a kind of a functional test of what is a suite of measurements that could be conducted on rover until samples are analyzed.
You got about 5 minutes left, Bernard.
Thank you. Eventually, we even found Mars in Sicily. This is a beautiful place called in Paterno, so which is where you can see some Martian mud pools and some CO2 gas going through, and also some alteration of the minerals. And you can see also how this affects actually some of the landscape in the mud pool, which is very similar to what could have been the ancient Mars. Eventually, we went there at a time very special where eruption started. So one night we were in the city and it started to rain ashes on our head. From 40 kilometers, we took our telescope to look at this eruption with a 400-meter plume going to the sky. But then the day after, we came closer in the observatory, an astronomical observatory, to see from 4 kilometers. And then you can see the lava going towards us at the safe slope speed. And so then we went on the volcano itself to study some of the sample and the site. So as a conclusion, clearly we have developed this EuroMoonMars program. It's open and we want to extend it to, we had a strong contribution from Europe and also from the US to it, but we want to broaden it to we have collaboration with other parts of the world. We are thinking of a campaign in Chile, Chile Moon Mars in the high altitude glacier in February next year, also Atacama. And so with these activities, we have data analysis on hand on data from previous missions, development of instruments for future missions, also validation of instruments that are flying to understand better the protocol for making measurements, but also training of astronauts in a realistic condition like we will have in future based on the Moon and Mars. We found also that there are tasks for not only for astronaut candidates, but for scientists, engineers, remote support. We have also humanists or artists that can join some of this campaign. So if you're interested, you are welcome to contact me. I put you my address at the Leiden Observatory. And in summary, this was an event at the International Astronomical Congress in 2018, where we had some members of our team that could come there. And you can see we are across the world, good gender diversity, and even we cover all the generations. So you are all welcome to talk to us and collaborate. And I want to thank again the Mars Society and for their role and the collaboration that we have had to start EuroMoonMars, but also to continue in some future collaborative projects. Thank you very much for your attention.
Wonderful. Thanks a lot, Bernard, for the overview and the insight into the EuroMoonMars project. All right, so we've got a question from Marufa, and they ask, High Seas and International Moon Base Alliance are two different organizations in one location?
The International Moon-Based Alliance is a legal institution that owns ICs, and actually, so there is a board of directors. So Hank Rogers and I am basically in the board of directors, and ICs is one of our projects that we have recovered. So the operation of ICs are under the International Moon-Based Alliance, but we have also other projects like some projects where we are going to deploy some robots, in particular to test some techniques of in-situ resource utilization and possibly build the base using the local material. So we'll have a step-by-step approach, and at some stage, the International Moon-Based Alliance wants to contribute to building a real base on the moon, but also accompany with some technology, research and development effort, also involving some commercial partners, industrial partners to be involved in what we test on Earth and later what we could deploy on the moon.
Wonderful, thank you. I guess I'll probably ask you the last question, and that is in regards to the ExoHab Lab module. So you mentioned that the 3D printers were used to produce some missing parts. Could you give us some examples of what are the kind of models that were produced, and maybe speculate on how in the future the 3D modeling technology will impact future missions and help members of the crew?
Yes, so ExoHab was a kind of a R&D project, and where in fact we repurposed some container or even a caravan and to equip it to see how you could share it in the function of half an habitat and half a laboratory, like you would do in some of the precursor modules on the moon. And indeed, we tested a set of experiments. A 3D printer, we worked with a material science group of ESTEC to see they have developed various techniques of 3D printings, a classical one, but even 3D printings that would use the regolith as a material. And so there are various technologies which were used. In the one we used, we used that more commercial device, but now we are looking at ways to incorporate 3D printers in some element that you could produce also as part of investigations. As well, we have even looked at some bio 3D printers. So for experiment where we could in the future even print bio organs. We even conducted a study of growing tissues or organs in the lab, like you could eventually in the future do on the moon and Mars for a transplant. So this has really evolved in many directions.
Thanks a lot.